Before we meet on Thursday, I want you to try a few things. Take your breadboard, take this thingy that's in the plastic bag out, and look at it for a while. It's got these numbers here. It's got something called 3V and GRD on the end here. Numbers 0 through 20 with lots of numbers missing in the middle, and then little annotations above them. Kind of try to make some of those out. What do they say? And right here you've got what are called pins, these little wires that are stiff. These are pins. And oh, it says pin right there. This is an adapter for the computer brain, for the microbit. So take it out first and look at it, but then stick it in the breadboard so that it's just along one edge here. These pins here. Not, of course, where the power is, but where these pins are, these holes are that put the pins in, and work them in gently so that they all push in all the way. And now you've got a way to connect wires to each of these pins. You've got 3 holes that are connected to each of these pins. And that makes it really easy to work with. So it's going to look like that, and it's going to get a slot right in here. And then take your microbit and gently push it in the slot, the top, with the lights facing up, like that. Perfect. So it looks like that, and that is a good way to work with it, and then we'll be able to work with it on Thursday. Take your power, get it powered up, and stick it in USB. And the first thing we're going to do is run a program that will light up your LED using the microbit. So the microbit will be the power for the LED. And what do you think these are at the end? 3V and G and D. G and D is another word for negative, and 3V is another word for positive. 3 volts positive, and ground. Ground and negative are all the same. So we're going to stick the negative leg into that hole, and the positive leg into the hole next to it, and we got light. So that's pretty simple. The microbit is a little power plant. It's taking the 5 volts in from here and changing it to electricity that is 3 volts now, and putting it in the light. So that's the first experiment. The next thing I want you to try is to use the microbit as a controller for the light. So these numbers 0 through 20, with some of the numbers missing, are ones that are in the software. So let's go to the software. Okay, start a new project and name it something, doesn't really matter. And now we're going to go way down to the bottom of the list in the advanced section. So undo the advanced section, go to pins. Digital write pin. Put that in forever. And we're going to pick a number that is on that adapter. We'll pick just randomly, just pin 2. And we want the pin to do something, but we want to have it pause for a minute. So we're going to put one of those pauses in, and then we're going to turn the pin off later after it pauses. So we're going to have 2 of the same things. Digital write pin 2, digital write pin 2. Make sure the pin numbers are the same. And in computer language, on is 1. So can you guess what this program does? So you can see what it does over to the left there. It kind of makes that thing flicker on and off. On, pause, off. On, pause, off. but it stays off for a very short time because we don't have a pause for off. So we're going to fix that. We're going to go way up to the top. We're going to grab another pause. And we can see how like the little virtual computer on the left there shows us what it's supposed to be doing. And we'll download that to our actual microbit. Okay, we get to see what our software did to the LED. Stick the leg into pin 2 and voila, the software is making the pin send electricity to the LED and creating that little pattern that was in the software. Go back to the software again and try different variations. Try to make a heartbeat. Try to make a heartbeat of a hummingbird or a heartbeat of an elephant. Different on-off ways to make it, like make a message, maybe on-off, and then a different pattern. Try different patterns before Thursday if you can. So with the LED experiment, we're able to create output. But what about getting information into that little computer brain? We were able to get information out and have it make a little heartbeat, but we want to figure out what's going around in the world and tell the computer brain some information, and that would be using a sensor. So we've got this in your package, and this is a proximity sensor. The closer your hand comes to these bulbs, it sets it off and sends a signal to the computer brain. So let's stick it into the breadboard. You want to go along one edge here, like that. So it's like that. Now tell me why, if you put it like that, it wouldn't be very helpful. If you were trying to connect pins to the pins on the sensor, you couldn't really put them that way. So we'll talk about that on Thursday. But for now, let's go ahead and just put them this way, and that gives us 3 little rows of pins to connect to. So let's just power up this sensor. The sensor needs some power to do its work. And so we know that there's power right here from the microbit, and we'll use our negative, which says ground here, and we'll look closely at the back of this sensor. It's got some writing here. So you want to match up the different connections. So ground here, or negative, is ground here. And so connect it to one of the pins in front here that corresponds to the pin on the sensor, right there. All right, so we've got ground connected between the microbit and the sensor. And then we want to power the other side. What's that? Voltage. That is positive. Now, there's another name for positive. It's voltage in, or VCC. I don't know what that stands for, but that is listed right there. So we're going to take the red and connect that to the corresponding pin there. And then we're going to bring it over to 3 volts. So 3 volts here, way on the end, is positive. So it's going to look like that, right there. And what happens? We have a cool little red light on our sensor. And we have power going into it. And now the sensor is taking in information about the world. And how do I know? Is because if I put my hand near that sensor, the little green light goes on. And you know, I've had a little trouble with this sensor. If I had to close the light, I have to close the curtains on the windows, because this is a sensor that uses light, and I think it gets confused by a lot of sunlight. But without sunlight, we're in good shape. We put our hand nearby, and it turns the green light on. And so we can take that information and bring it back to the brain using this last pin that we haven't used here. It's called out, and that called signal out. A signal is like a kind of language. It's using electricity not to do work, but to send information. So this information comes out of this little pin, and we could, well, I want you to, we'll talk about that on Thursday, but I want you to figure out what could we do with this information that the sensor is giving us. For right now, we could just put the out in some, random place. Maybe let's put it here. This is not connected to anything, because remember, this little canyon in the middle is disconnected. And so why don't we just use our LED and connect one end to, okay, let's see if we can get information out of this sensor. When it goes on, you put your hand there, see what happens when we connect the out to the negative leg of the LED. That is the one that is shorter. And then the one with the, oops, my LED came apart. And then the one with the resistor on it, this little blue thing here, this will go to positive. So we'll stick the positive in one of the little holes that corresponds with the positive pin here. And what happens when we trip the sensor? The sensor goes on. Oh, look at that. The light goes on. And maybe you can explain that to me on Thursday. Try to set that up. And if you have any trouble, send me a question or we can talk about it on Thursday. Look forward to seeing you.